Good evening, everyone. Hi, my name is Neha Jaswal, and today I'm going to take this webinar on project-based learning. I'm going to present my screen so that you can see the activities. I hope you all can learn today something, and it is linked to the previous webinar only. Let's start this. So, project-based learning with robotics. And the motive is here to understand that how the classroom concepts, which is related to STEM, is getting converted into real models. So project-based learning is always followed by activity-based learning, small activities which we learn in the class through the concepts and different laws given in science, in mathematics, in engineering. That laws has been followed, and with the help of activity-based learning, we show that to the students, to the educators, and they give us the idea of how using those activities we can convert into the innovative projects and make the learning stronger by building the projects. So the future of learning is experiential. Hands-on learning is very important to understand that how this STEM knowledge, STEM concepts are useful in robotics in every field nowadays. Now everybody know over here that according to NEP, the STEM education is now mandatory, and we have to follow hands-on learning. So the concepts which you are already telling the students in the theoretical form, you can show them actually using the STEM concepts over here, right? You can show them with the use of activity based learning. Correct. Active creation means that PBL transforms students into creators. They are not just learning the concepts, they are actually learning how to relate those concepts for making the innovative projects. We are making the students future ready over here. We are preparing the student for tomorrow's challenges. I would like to show you one video so that you can understand that how this, just a second, how this is going to help the students to understand a very small logic of motion and force with the help of this video. There you are. So here I am showing you a simple concept which is from the science concept, understanding the force over here, right? What is friction force and what is pushing force, right? So here we have created one robot over here, and to understand that how F is equal to ma is applicable on it. So we have built a robot over here, and we have taken three different weights over here by filling the container to understand that how the weight is actually how the mass is actually related to the force, right? So we have measured over here, and let's begin the experiment. After the first experiment is going to show that if the weight is very if the weight is very less over here, the F1 is equal to m1 into a is high. And here, if the weight has been increased a little bit, then what happened? And then the weight has been increased a little bit more, then what happened? So what happened that when the weight was high, the frictional force was less, right? So F1 was lesser than F2 and F2 was lesser than F3. So from this activity, we understood that force is dependent, right? On, yes. Yes, from this experiment, we understood that force was dependent on mass and acceleration, right? So this concept is already taught in the school, right? But we have to show them with the activity so that they can really understand it, that how it actually works, by giving them the visual ideas over here. What is project based learning? So whenever the student actually create anything, making sure that it's a solving a real problem of the with the use of meaningful projects, that is known as project based learning. It actually encourages the student to think, having a critical thinking, to create something, to innovate something, and to do the collaboration as well. So it integrates all the concepts: science, technology, mathematics, and engineering. I have few examples over here which I will show you as well. Like for example, vowel creativity with coding. I would like to show you how it works. Okay. So we have a platform over here which is known as AI Connect, and AI Connect is one of our platform which AI Connect is one of our platform which we have created to make sure that the students are not having much issue with the text-based coding, and they can, by the other hand, they can also run their projects with the easy, simple steps. That is why we have created it in a block-based coding. So let's say if I'm running it, it's a simple project of just understanding that this particular letter is a vowel or a consonant. So if I'm writing, entering N, and I'm entering it, it's showing that it's a consonant. So I would like to show you that how the coding will be done. Let's start with creating a variable. So creating a variable is very important. Likewise, I have created over here. I'll create, just a second, I'll go back. This is the platform. I'll start with basic coding. Over here, I'll create a variable. Is very important to create so that you can understand and give the and use it wherever you want, right? So I'm setting the letter over here. What to what? Because I am working with the simple letters and simple alphabets only. So I will just take as an input, and I will write that enter any letter. Sorry, enter any letter. Okay. Then I will take one logic of if else. I can add the else over here. In the logic I would take, so I'll take simple that if the letter, the variable is the given variable, if the given variable is, I have to take like there are 5 vowels, right? So I have to take a few logics over here. That will be or logic. That if the letter is A, or, then I will duplicate the whole thing. Then I'll make it I. Then I'll take another logic again, or I can simply duplicate it as well and put it over here. If the letter is A, I, just a second. O, A, I, O. Sorry. Just a second. It's not taking. Just give me 1 minute. It's having a glitch. Just let me, yes, just a second. Just let me know that if you can see my screen. Can you see my screen? Okay. So let's say, for example, if I have taken this, that if the letter is A, then you have to take an output of simply printing it's a vowel. Else it will print it's a consonant. So let's check it out. If I'm printing A, then it's showing that it's a vowel. Otherwise, if I print anything else, I have not given the command of E, I, O, U right now. I'm just showing you other. It's a consonant, right? So I'll go back here. So this was the vowel activity which I showed. Now there are many activities which you can do over here, which is a mathematical concepts over here, or a graphic design you can do. Let me show you that activity as well. So I'm going for AI coding. Let's say, for example, if you want to tell the students how to do the graphic design with the help of with the help of coding. So I'll go to the variable. Let's say I'm just making a variable n over here, and I'm setting the variable. Now, if I'm doing the graphic design, so I will uh, set the turtle. Turtle is a syntax in the Python coding. So I have set the variable over here. How to design it? So if I will take if I'll show that this turtle will move forward for 50 steps. Let's say, for example, if I'll take n and move forward, if I'll run it, it will show like this. Fine. So this is how, if I'll just increase the steps like 100, it will show like this. Okay. So let's say, for example, if I want to make a square over here, how to make it? So I'll just go to motion and I'll turn to 90 degree. The same variable will turn to 90 degree. So you will see by this, you will see this arrow will be turning to the 90 degree over here like this. And again, if you will duplicate the same coding, it will go up and it will make the 90 degree with the same 100 steps. And if you'll do this activity, this coding for 4 times, right, then you will be able to make a square. So instead of doing this coding for 4 times, we'll go for the loop and we will repeat the whole process for 4 times. I'll take this, I'll just repeat it for 4 times, and you will see that it is creating a square, right? Similarly, if I want to create a triangle, so I'll just simply use the logic, and this is all. There are multiple things which you can do over here with you can change the color, you can change the speed, you can change the width of it. I'll just show the width of it, how the wideness you can change over here. So it's a turtle character. So let's say, for example, if I'm making it 20, it will be like this. Okay, you can change the color as well. Fine. So these are the activities which I showed on AI Connect. It was just to tell you that how we can use the coding and how we can incorporate the coding to show small concepts of mathematical concepts and science concepts, engineering concepts. I would like to show you one engineering circuit activity which will show a very basic of engineering concept, which is STEM paper circuit. We actually call it STEAM. STEM is for STEM doesn't include art. We include art over here as well. There you are. So these students, this is the STEAM paper circuit. So what they are doing is they are coloring the sheet over here. And after coloring, they will start making the circuit with the use of copper tape, right? Copper is a good conductor of electricity. Everybody knows it. So we are using a copper tape and we are making sure that these activities are handy for the small children. So the circuit designing is already done with the positive and negative marked over here, and everything is marked that where the LED will be putting over here and where the coin cell will be, the power supply, which is coin cell, where it will be used. So once the circuit is completed, you'll see that how they are placing the components over here as well. So they are placing the LED, which they already know that what is anode and what is cathode. And here they are testing it. And with the help of the art they created, they will show you the output over here. Over here, right? So this is the output of the activity. Fine. So this is how they are showing that small concepts of electronics we can show over here, and we can encourage students to participate, to understand, and we are basically giving them the path to understand that how these concepts they can learn easily. Fine. So this is a windmill activity. You can see on our STEMROBO page as well. I'll show you here as well. So windmill, we are already teaching the students this concept. And here with the help of a simple Mechaton kit, the kids have created the activity over here. See, there are metal parts over here which they are assembling with the use of screw and nuts. This this also helps to enhancing their motor skills as well. They are attaching it, they are creating it, they are using their creativity as well. And here you can see they are applying a motor which is connected over here with the help of a mini remote control there, and with the power distribution they are actually able to turn it on, right? So here not only they are understanding the concept of windmill, they are actually participating it, they are actually feeling it, they are actually knowing it, that how actually it shows, right? So activity based learning is very important, and that only converts into project based learning. So in the previous slide which I have showed you all the like science laws which can be shown with the help of robotics, the circuit I have shown, the mathematical and geometry I have shown, and the logic I have shown. And these learning actually becomes long lasting because the students are experimenting it, the student are actually experiencing it with the help of seeing it, touching it, and creating it, which also enhance the curiosity. Okay, why robotics enhance PBL? So whatever, let me give you one example of Arduino Uno, which we are going to address in the coming slides. So Arduino actually works like a brain. So let me give you one example. Like I'm a human and I have a brain, right? My brain functions my overall body. The organs we are functioning, right? With the help of brain only. So Arduino also works for the same. Arduino also works is a microcontroller which works as a brain only, which actually helps the external components to function with the help of coding, like our nervous system give the information to our body parts. Same similarly, the coding is what? Coding is just an information, right? In such a manner which can give information to different parts, different external parts, which can be run by the brain, which is known as microcontroller Arduino Uno. Okay, so the basic concepts of movement and sensors, which is under the theory right now, we can actually make them understand with these concepts how they are running with showing some small activities. Experimentation, while doing the project they are experimenting many things. Even if a register of some kilo ohm is wrong, the project will not work, right? So the experimentation, trying and knowing the error, and iterating it, founding it, that what is the real engineering and what is the critical thinking behind it, it's very important for the project based learning. Engagement, the curiosity, you are basically engaging yourself and the students as well, right? You are basically enhancing their curiosity, motivating them for doing the hands-on experience. Okay, so this is the PBL cycle, and in the next slide I am going to tell you how we will be creating one project over here. So ideating it, identifying a challenge, it's very important. As you all know that everyone, even the Niti Aayog has given us the sustainable development, the SDG goals, right? Sustainable development goals. According to that, that whenever we are thinking for making any project, we have to think in such a way that if there is any kind of societal problems are going on, take that challenges, identify those challenges, and then do the research, build some build some circuit, build some ideas, assemble the components, do the coding around it, program it, test it, what are the errors, just identify the errors, and then once all are done, then present it in the final model, right? This is the PBL cycle for any project which you have to do. Okay, so from concept to real model, I'm going to show you an example of smart dustbin with a very simple way. Okay, with the use of block coding, how you can do it, with the use of text coding also, how you can do it, that I am going to show today. So the concept is taken for the smart dustbin is that whenever a person want to dispose a waste, there will be no touch, it will be contact less, right? Though the prototypes are, many prototypes are made already. I will show you a real model also. I have a video of my student, I'll show you that working model as well. Okay, I'm going to Tinkercad. So Tinkercad is a platform over here which will be used for making and testifying the circuit, so that you can actually know about your activities and projects what you are going to make before making it, before converting it into the model. Okay, testifying is Tinkercad is the best platform over here for testifying the circuit. So first I would like to show you the model of a smart dustbin with a circuit and a schematic diagram as well. So here I'm starting the simulation. Okay, so the dustbin status, it is showing open. Okay, why it is showing open? Because in the coding I have given it closer. The person is standing closer to the ultrasonic sensor. Okay, if the person goes away from the dustbin, it will show that dustbin status is closed. Fine. And you can see the servo motor over here. Servo motor is actually representing the flap of the dustbin, which will be opening and closing with the help of it. Okay, if a person is coming closer and standing closer to the dustbin flap will get open, the status will be showing opened over here. Fine. Okay, So here I have used 4 components: Arduino Uno R3, ultrasonic distance calculator, servo motor, and LCD I2C. Stopping the simulation, I'll show you the schematic diagram. If somebody wants to create a PCB of it, they can create it. Okay, this is a schematic diagram of it. I'll go back. Let's start the activity. So I'll show you with the block coding so that you can understand and you can make students understand in an easy way that how to create such tough projects in a very easy manner. Okay. So here is create circuit. May I know in the chat box that who is new on Tinkercad? Okay. Okay. All right. So many people are new in understanding Tinkercad, so I'm not going to make it text based because it will be a little bit tough, but I will definitely tell you that how you can use that text coding from here only to for your programming and for making it as a project. Okay. Okay. So first, I'm going to just give an introduction. This is a Tinkercad circuit platform. Here is the circuit making. Okay, here you can duplicate, you can copy, delete, undo, redo. You can, if you want to comment on it, toggle on it, you can do it. You can change the color of the wires from here. You can rotate any component and you can mirror any component. Fine. Here is the components, which is virtual components are provided over here. Few components I would be taking, like I'll be taking a small breadboard over here. I'll be taking one Arduino Uno R3. Then I want, first I will tell you about ultrasonic sensor. This I am taking and I'm attaching it over here. And first I'll be taking a buzzer just to show that ultrasonic sensor is working or not. Okay. Then after on I'll be adding the components with the coding. Okay, step by step. So I have already given introduction. I've already given an introduction of Arduino Uno R3 as a brain, as I told you that we have to connect the external components to it to make sure that they all are working as an activity and a project. And this will work only with the coding, right? Without coding, it will not work. Otherwise, it will be worked as simple power supply. Okay. Right. So I'll start the connection over here. So I'll be taking a simple ground and making it ground. I'm just changing the color for your reference. The black color is referring to the ground, the negative supply, and red color is for the positive supply. This is that. Okay. So whenever it is required for any component, I'll be taking it from here. So here you can see this is VCC of the ultrasonic sensor. So I will just connect the VCC to over here, and ground you can see over here. So I'll be just taking the ground. I'll be connecting to the ground supply. I'll change the color of it. Here it is trigger pin and eco pin. So I'll be taking a trigger pin and I'm connecting it to pin number 7 over here. And I'm changing the color. Then I'm taking echo pin and I'm connecting it to pin number 8. So ultrasonic sensor is basically we use for distance calculator. Basically we use for a distance calculator. Might be you have seen whenever you are entering through a glass door in a mall, it automatically closes itself and automatically opens itself. So there is an ultrasonic sensor which senses the distance of any person which is coming closer to the gate, right? So this is what we are doing over here. And this trigger pin and echo pin is the main function over here. Basically it's a receiving and the sending of a signal, and through which it calculates the time. Okay, so here we will connect with the buzzer as well. So the buzzer negative I will connect to the ground, and positive I will connect to the pin number 2, so that we can take it as an output pin here. There you are. So the coding, the circuit designing is done, and now we have to do the coding. So in the block-based coding, I will tell you how to convert it as well. So I'll just delete it. I'll just delete this as well. So what I'm going to take is, so I need that if, I need a if condition, that if ultrasonic is sensing anything with certain distance, then the buzzer will be high, right? This is the idea of doing it. So I'll be first taking the control over here because I need if else condition. So I'll be taking if else condition, and I'll just check, sorry, I'll just go to math because I need comparison over here. I'll just check that where the code of ultrasonic is given. So I'll just check that. Just let me zoom out. So here ultrasonic pin, trigger pin I have connected on pin number 7, and echo pin I have connected on pin number 8. So I'll be taking that. I am measuring in centimeter units, so I'm not changing it. And here I'm making it 30. Okay, 30 centimeter. If it is less than 30 centimeter, if ultrasonic sensor is sensing less than 30 centimeter, then what will happen? The output I'll be taking, that pin number 2 will get high. Okay, the pin number 2, which is our buzzer pin, will get high. In else condition, I'll take, it will get low. For the people over here who already knows the text-based coding, I'll show you that it can convert into text as well. And the same text you can use, you can simply copy it from here and you can use it in Arduino IDE. It will totally work. Okay. So this is the um, ultrasonic library. Sorry, we have used the ultrasonic library over here, and these are the syntaxes of it. Okay. So I'll go back to the circuit and I'll show you the simulation. Okay, let's see, let's demonstrate it. So here you can see it's greater than 30 centimeter. Let's go. Let's, means our circuit is working, right? I hope you guys understand. If you are having any questions, ask me in the chat box. Fine. Okay, so now as we have already checked it for the buzzer, so let's check it for the servo motor as well. Okay, I'm stopping the simulation over here. Instead of buzzer, I'll just delete the buzzer from here. I'll just take a servo motor from here. So there you are. I'm taking a servo, just deleting it. I'm taking a servo over here. Fine. So this is the ground pin, and servo motor is a quite different motor. There are multiple type of motors. Servo motor basically works for a particular angles only. Okay. So ground and ground we have already connected. So I'll just make it ground over here. Changing the color. This is power pin. So I'll just give power over here. And this is a signal pin. So signal pin again, I'm gonna use pin number 2 only. And this line I'll delete, which was connected. Okay. Changing the color for the reference. Okay. So in the code, obviously, we will change it, right? So what we will do is, now we don't have to check the buzzer. So I'll just delete that. I'll just go to output, and from the output, I will just take rotate servo, right? Servo is connected to pin number 2. I would be wanting that whenever the ultrasonic is sensing anything, the flap is getting open by 90°. So I'll just take 90°. Whenever you will make the project, you need to understand that how you are connecting the servo motor at which location, and what will be the, whenever you are opening the flap, it's not necessary that it will open only on 90°, right? So it can open, it depends upon that how you are placing it in your project. Okay. So I'm just duplicating it, and just for showing the difference, I'll connect it to 0°. Okay. So let's check. Starting the simulation. Sorry. There you are. So if the person is standing away from the dustbin, the servo is not rotating. If the person is coming closer, the servo will be rotating for 90°. Right? And if the person is standing over there, it will be remain same at the 90°. It is not that it will go back, because we haven't coded for, right? So if it is not sensing anything, then only it will go back. Okay. I hope you understood. You can just write in the comment that if you understood the concept of it. Okay, let's move forward. Okay. Ashu has said that please show the code again. Sure, I'll show the code again. You want me to show the code in text or block, or in both? You can see over here. So here again, let me explain the code. So what we have done is, we have included the servo library. We have written the syntaxes over here in the text base, I am telling. Okay. And then we have assigned the values over here. We have attached it, and we have given the condition of ultrasonic sensor that if it is reading it and the distance is less than 30 centimeter, then the servo will be opening by 90°, and otherwise servo will be at 0°. Okay. So you can see a huge difference between the text coding and the block coding. That is why block coding is always preferable for the starting students, right? If the students are at the smaller stage and they are highly interested in robotics, so you can tell them with this logic. Okay. So I'll just go back for the next part. So this is the whole project which can be shown. I will show you first the activity which my student has already created. So I would like to show you that first, and then I will add one LCD to it as well. So this was the student who created the smart dustbin without LCD that I am showing. Okay. Good morning all. My name is. There it is. So here you can see that this model is obviously not completely made. Thus the circuit testing was going on. So this is the ultrasonic sensor which we have placed in the dustbin. The entire circuit is inside it. This is the flap which is cut half from the middle of it, and the servo motor is attached in between. And you can see here that whenever Whenever any object is coming, the flap is opening, and otherwise it is getting open. Okay, here you can see the servo motor is placed over here. Okay, so the real project was like this. I'll show you. This was like that. Okay, so it's very important that you how you are presenting your project as well. Okay, so yeah, somebody has asked that how can we access these platforms. So these platforms are basically created by STEMROBO. You can connect with us. I will share one link also. If you want a free demo for certified educator program, you can connect with us there. We can talk about it. Okay, so this was the code. Now here, if I want to add the LCD I2C as well. Okay, so how to do it? This is LCD I2C. So what is the work of LCD? For the display, right? For this LCD, you can see this is the ground over here. Again, the common thing is that ground and VCC will always be there, right? So I always prefer connecting the ground and VCCs first so that there will be no complexity and there will be a clear understanding that which pin is what. Okay, here I'm connecting it to positive and giving the same red color. Now Arduino has the pin SDA and SCL. It has the clock pin and data pin which you can directly connect. If it is not working, in particular Arduinos it doesn't work or it doesn't support if you are using the pin number 0 and 1 at the same time, so you can use pin number A4 for SDA and A5 for SCL as well. That will also work. Okay, many of the engineers don't tell you and many of the educator doesn't know about it, so I thought that I should tell you. Just a second, I'll just take SDA from here and I'll just connect it over here to the SDA pin and just changing the color, and here I'm taking SCL pin and connecting to SCL pin of the Arduino. There you are, changing the color. Yes. So now I'll do the coding as well. Here, if you'll see that LCD is kind of output only. So here I'll go and print. So whenever the servo is getting open, it will print that dustbin open. Okay, I'll just duplicate it and put it over here, and here I'll just write dustbin closed. Okay, but what will happen, I'll show you. Okay, I'll just open. Yeah, I'm just starting it. Now you will see dustbin closed, and then again it started something writing over here, right? See, there is no breaking of it. It's writing and writing and writing. Correct? Let's say, for example, if dustbin is open also, so actually the servo motor is rotating. It means the flap is opening, but the LCD is not showing. But actually it is showing, but it is not coming on the screen because there is no clearance of this screen. So here comes the logic of clearing the screen and giving or providing the column and row of LCD to start with. Okay, so this is clearing of a screen, which is very important. Okay, so there will be one loop that it will print also, and by the other hand it will clear the screen as well. I'll use it for both. You'll see the difference. Let me show you. It's taking time. Just a second, it's taking time. Let me reload the page. So I hope you understand. So in the very first, which I told you, when I took the breadboard, ultrasonic sensor, a buzzer, and the Arduino Uno R3, right? So that activity which I showed you, that activity was basically a car parking siren. If you can relate that, we have, whenever we drive and whenever we are parking our car in the back gear, right? So what happens actually? So if the object is, if your car is coming closer to any object, it beeps, right? That was the very first activity which I showed you. That is a car parking alarm. Okay. And then we shifted to servo motor and so on. Okay. So every single activity actually tells you that how these components can be used of project based learning, right? How we can use it in making the projects, because smart dustbin also is a idea of someone, right? Let's start the simulation. Okay, it is creating some issue. Just a second. I'll just reload it. While it's reloading, just let's go to the other slide. So real world robotic applications are aligned with sustainable development goals, which is given by our government, right? So robotics projects actually helps to make sure that students and educators knows about the real world scenarios, what are the problems, what the problems are, because if you know the problem, then your mind can think about the challenges, think about the solutions as well, right? And once you know the problem and the output solution, then you will sure make the way out of it and you will experiment about it, right? So these are something which I have showed, that autonomous vehicles, which is used for the with the help of technology only, we are now able to make a self-driving car as well. Smart farming, with the help of IoT, we are already creating the smart farming, smart alarming and smart farming both, right? And disaster rescue, that search and rescue robots for emergencies, which is already created. Home automation system, that is also IoT based system. We have already seen many of the projects of it. Navigation robots were like obstacle avoiding cars and many things, right? Line follower, obstacle avoiding, which are already in use of solving the problem. So the skills, what they are developing, the students or the educators, what we are developing through these project based learning: the critical thinking, because we are thinking in a particular way for a particular project. We are communicating with our team, with whom we are working. We are designing it, we are thinking about the designing, we are coding it, we are creating it by giving a proper look of the project, and then we are collaborating with the different collaborators to tell them about your idea and the projects, right? So this is how the in particular in robotics project based learning is used. So how the educators can be benefited from it: so whenever we are teaching in our classes, instead of taking a theoretical lecture, we can actually create a fascination in the students, create a curiosity in the students, that how they can learn with the visual and activity based learning, right? STEM confidence, learning the STEM concepts with with the help of hands-on activities and experience, that gives another level of confidence. We will be able to manage our project. We will be able to uh, plan our project and execute with our skills, which we will be learning throughout our childhood, with the help of STEM concepts. Enhancing the engagement, we are actually creating the next generation, and we are making sure that the learning outcomes and whatever we are doing in the classroom, they will be doing in the technological world outside. How the school is benefited over in this. So in basically we are working towards the 21st century STEM ecosystem, right? We are giving the knowledge in such a manner so that we can prepare the students for the tomorrow's challenge, right? We are strengthening the school uh, by their by giving them a reputation that they can enhance their brand value. They can tell the parents that how it is going to help the students, right? And for creating them, for making them, or um for making sure that the students are getting prepared for 21st century skills. There are multiple schools which are having ATL labs and robotics lab and AR/VR labs, and that is actually helping the students of understanding the STEM education closely. Innovation culture, basically it is all about building the mindset, how with the creativity and the experimentation we can actually solve the real life problems, and we can devote to our society, right? Students, how the schools, because the school is directly working with the future of nation, right? With the students. So basically we are preparing the student for robotic competition, science exhibition and innovation, which they can showcase their talents over there. We are strengthening the students by with the preparation of their of their portfolio, right, for the future. For those students, what they will get the strong technical foundation, because if the student has started learning from the KG onwards, and they are actually knowing that what is activity based learning and what is project based learning, so actually they are going to master it by the end of then, when they are starting taking the steps that where in which direction they have to go. We are giving a engineering mindsets over there so that they can develop a systematic problem solving skills in themselves. We are giving, obviously they will create a good portfolios which can demonstrate their practical skills as well. We are creating the students over here, they are future ready with the career skills, right? We are enhancing the creativity as well. Which, if you want to learn coding using robot, which robot would we use? So there are multiple robots actually. We in the STEMROBO we call that robot Echo. We are already the Echo is already under the process. Every single day she is getting ready with the different type of machine learning and coding we are giving to her. And definitely there is a one uh, uh, today only I was seeing one site, I don't remember that name, that it was showing a tree over there, right? And if you are questioning anything, which was created for class 1 to class 12th, okay, with the help of the syllabus and the content. We and the STEM robo also, we are having a DPVR headsets, which is the student can actually experience that they are actually having a VR set, and they are actually seeing all the concept like solar system, human skeleton and so many things which they are seeing in the VR modules, right? So there are multiple AI agents as well. There are multiple bots as well, which you can use in the STEM education. So coming to the slide, these are the case examples: that automated irrigation model, obstacle avoiding robots, smart city, traffic system, humanoid mini robots. These are the real world projects which are already showcasing that how students can be using their PBL knowledge, project based learning knowledge, for creating such innovation and practical projects out there. Okay. So in the last part, I would like to conclude with that how we are bridging the learning to the real world skills. So project based learning is actually very important, which is based on science, technology, engineering, and mathematic concepts only, STEM education only. And it's very important that with this STEM education, we convert those ideas with the experiment, with the use of experiments into projects. Okay. We are making the students a new creators and new innovators by giving them the platform over here. We are helping the society for future ready learners. So learning by doing and learning for life, this was the slogan I wanted to tell you. I would use some time to tell you about the certified STEM educator program which we run. This is a CSEP program, and in STEMROBO, we want not only the students, the educators of this era also wants, because you educators are obviously here to know that how to upskills ourselves, right? You guys are very skilled already. The students, they are already very skilled. That, but the technological world is changing every now and then, and it needs that every single time whatever new technology is coming in the market, you should know about it. You should know about it. You should upskill yourself as well. So certified STEM educator program is provided by STEMROBO. You can see a replica of a certificate as well. This is a course of 6-month course which we are providing. You can get I'm sharing one link over here. Just a second. I'll be sharing one link with you guys. So you can just do the query, or if you want a free demo, or you want to understand that what this program is, so it will help you. Just give me 1 minute. Sure, I'll share third last slide. Just a second. Just give me 1 minute. I'm just pasting something in the chat box. Okay. In the chat box, I have just shared a form link. Basically, it is for receiving the information about the entire CSEP program. So you can fill the form if you're interested into. Let me tell you some more about it. Just let me know that you were asking for this slide, the conclusion slide. I can share the all class slides. This webinar will come on YouTube. Definitely, you can see from there. Okay, you can just go to STEMROBO Technologies. There, all the webinars are already there, and you can definitely see the whole recording. Okay. All right. Okay. So yes, I was about to tell you about the certified educator program. So here we are giving the certification, and this is a whole soul program. You can get all the information by filling the form over there, and it's the link is already given, sir. The link is already given for certified educator training program. So the key objective is that to train the educators. Now everybody knows about the Atal Tinkering Labs. Still, I would like to tell you about it. Atal Tinkering Lab is one of the initiative of government. That is, there is a government body known as Niti Aayog. I hope that many of you knows it. YouTube channel links, sir, surely I will send it. Okay, I'll just send it in a few minutes. Okay. So Building the competency in project-based learning and design thinking. So whenever you are working in a project, so there is a particular mindset that what will be the designing of the project, what will be the coding of the project, what are the experiments and errors of that project, and then a project get ready. Okay, enhancing the understanding of NEP 2020 and how it is aligned with the STEM curriculum. So I would like to tell you one more very important thing, that STEMROBO, the curriculum which NEP, which Niti Aayog is following, that curriculum is actually made by us only. And our whole program, whether it is certified educator program or the curriculum which we provide to the schools, everything is aligned with Niti Aayog. So you can definitely trust on us on this. Support teachers in delivering AI integrated and IoT enabled learning modules. So basically, we are here to support the teachers to understand that how AI, ML, and IoT, what are the learning modules of it. There are 5 module in CSEP program. Module 1 is game development, module 2 is app development, module 3 is robotics, module 4 is 3D design, and module 5 is Python. So the person who was asking about AI Connect, actually it comes under certified as STEM educator program. We will create a credential for you once you will take the program, and there we will create the AI Connect credential as well. So in that module number 5, you can also learn about the block coding, and which will be only done on AI Connect platform, because nobody tells you the coding in block form. And I have personally experienced that students only try to nowadays the student doesn't want to write the program, they wants the very easiest way of doing the programming. So AI Connect is one of such platform. Okay. Training certificate you will get after completing the training. There is a proper time frame will be given to you. There will be 6 month training program will be given to you. Okay, it's a self learning training. The whole content and everything will be given to you once you are registered. And then after, there are 2 live doubt clearing sessions will be going on every week. So whenever you are having any doubt of that week, you can definitely join it, and the joining link and everything will be provided on the first day of registration only. Okay, so you can join it and you can just clear the doubts. Rest all is self learning, and whenever you will be having a doubt, our trainer will help you to clear the doubt. This is how you will get the certificate at the very end. Definitely, if you are working for the certification, then you have to go through something in the mean, like you have to create some project for us. You need to understand that how we are working in a particular channel. You have to work in a particular module, you have to work, which will be provided under the certification program. Okay, so I'm just sharing the YouTube channel of STEMROBO, which you were asking for. Just a second. Um, Fees and everything will be discussed once you will fill the form. There is a other team. I don't have any idea about the fees and everything. You can discuss over there. Okay. Yes. Questions. I'm ready for the questions. I was not able to log in to my STEMROBO login credential to AI Connect. So if there is any problem in using the credentials, you can directly connect with the person to whomsoever you are in the connect, and you can tell them that this is not particularly working, and they will resolve the query. Fine. PPT I can't send. Sorry, Prasadi, I can't send the PPT, but you will see the whole webinar on our YouTube channel. The today's training certificate will be provided to you. That will take time. You will get it. If you want to learn coding using robot, which robot will we use? Okay. These are the repetitive questions. If anybody is having any query related to the today's um, topic, which is PBL, Arduino, and AI Connect, you can ask. The certificate will be given to you because you have already, if somebody has registered, whoever has registered, they will get the certificate. You can go to the same registration from where you have joined to collect your training certificates. Okay, and you will be getting notifications as well once the certificate is ready. Okay, so is there any query related to the Arduino or project based learning? So I'm happy to help over here. Okay, Geeta ji, for sure, I will talk to the team and you will get your certificate. Thanks, Amandeep. Thanks, Gina. Anybody else wants to have any query? Thank you. Thank you, Sabia. Thank you, everyone. I hope you got some enlightenment today regarding Arduino and projects. Great. Thank you so much for joining. I'm definitely going to work on the certificate part. Don't worry about it. Thank you so much, Kanchan. Okay, great. Okay. How to prepare Lego robot using Bitly? Okay, I'm sure you know about the Bitly. That is why you are asking the question. Using Bitly, you can use the same platform AI Connect. AI Connect, we have given the particular like Tinker Orbit is one of our DIY kit, and Bitly is one of our DIY kit. STEMBot is one of our DIY kit. So there is a particular curriculum which we are providing. In that, step by step, everything is provided. If you want, you can just go to our YouTube channel, and over there also we have shared 2 to 3 projects. You can see from there. Okay. Okay. Yes, the demo is free, and the person will connect with you. Okay. Yes, there is a manual of Mechaton as well. Mechaton is one of our DIY kit. Yes, there is a manual as well. Sure, Gitanjali, you will get some more sessions on it. Well, AI can be used anywhere, Mehraj ji. AI can be used in any subject. It can be interfaced with anything. It depends upon that in which area you want to work. There are multiple AI agents. Let's say, for example, in before this webinar, I was working on Kahoot quiz. So it depends upon in which area actually you want to work, in which subject you actually want to work. Arduino kit, yes, you can get the curriculum of Arduino kit. It all depends upon that which curriculum do you want. Okay, you have to connect with the team for that. Surely, certificates will be provided to you. Okay, I'll connect with the team. Okay, I'm closing it. Thank you, guys. Thank you for being patient. Thank you for joining the session. Um, Rimi ji, actually the manual, it depends upon that the which kit you are having. The manuals are provided for the kits, for the DIY kits, which is only for the fourth grade, third to fourth grade standards. Okay, if you are having Arduino starter kit, electronic box kit, Mechatronic kit, so there will be a curriculum which is on our LMS. That is a different thing. You will get all the content, but not in the manual form. It is given in the LMS form. Thank you so much, guys. Thank you, everyone. You can use uh, the link for CSEP, okay, Certified Educator Program, if you want, if you have any query. Okay. Have a good evening. Bye bye. Take care.